Have you ever looked at engineering and then looked at the medical field and wondered if there was a way to combine them? Well, that is exactly what biomedical engineers do every single day. Hi, I'm Sarah, a biomedical engineering major here at USC Viterbi from St. Paul, Minnesota. Biomedical engineering, or BME, is the intersection between engineering and healthcare. We combine principles of biology, chemistry, and medicine with principles of engineering design, physics, and calculus to design medical devices to move the medical field forward. We do everything from engineering tiny cells and tissues to engineering larger scale things like prosthetics and surgical devices. To me, this field is the perfect union between problem solving and patient care, where we get to design devices and then directly see how they impact patient lives. In high school, I was the quintessential aspiring pre-med student in all the biology and chemistry classes and all the healthcare-related activities. And yet I still loved the problem-solving aspect of my physics and calculus classes. So when I heard about BME, I realized this was the perfect major for me. I love getting to identify problems in the medical field and then using concepts learned across all my different classes in a lot of different disciplines to design devices to actually address and solve these problems. BME majors, like most engineers, take classes like physics and calculus. We also take biology, chemistry, and often even organic chemistry. However, the majority of our coursework comes from the actual BME curriculum. We take courses such as medical electronics, physiological systems, nanomedicine and drug delivery, and orthopedic biomechanics. These courses combine principles of coding, calculus, and physics specifically to medical contexts. Through this, we get to learn technical skills and then use them to look at biological principles in an entirely different way than pretty much any other major. One of my favorite classes that I've taken for a major thus far has been BME 202, Control and Communication in the Nervous System. In this class, we've been examining how action potentials work by looking at the individual gates inside of each individual ion channel in a neuron and then scaling up from there. We've been modeling the cell and the cell membrane potential as a circuit, and then using differential equations and Excel to look at the way a cell will respond to a stimulus. I've loved getting to look at such a biological concept and apply engineering principles in a hands-on approach to understanding it better and looking at it from the perspective of an engineer. BME grads have a lot of different directions that they can go in. I personally am planning on attending medical school after graduation, and then working as a pediatric specialist with children who use medical devices. A lot of BME grads go into industry and can do all sorts of things within that engineering field. From working in research and development, or even consulting at a large biotech company, to working at, or even starting, a startup medical device company, there are a ton of opportunities within the biotech industry. Some grads choose to go into engineering outside of the biotech realm, since our technical skills can be applied to many different aspects of engineering, and we truly do learn about all the different sides of the STEM field. Other grads choose to get a master's degree or even doctorate degree and enter the academia world, where they can continue to do research and design solutions to medical problems in that way.